Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairul Kimi Bezabah. Today I want to explain about the task 1 in part addition. So we can see two diagrams at figure A, 1A and figure 1B. Figure 1A is show x1t and figure 1B shows x2t. So I want to make addition both of this signal to find zt. So first step, I want to find an expression for each signal for x1 and for x2t.
So now we have to find x1 and x2 in unit step function. So first thing, we can distribute x1 graph into 4 parts. At first, we need to find the gradient of all parts since they are all in ramp function, and then the gradient are the same for part 1 to part 4. So we can use the gradient formula to find the gradient is equal to 2 by using the coordinate function. This is the first coordinate x1 and this is the second coordinate x2y2. Then the second thing is we need to find the direction of all parts. Part 1 and part 4 are upward direction, so it's in positive sign, and part 2 and part 3 is in negative direction, so it's a negative sign. And then the third thing is we need to find the time shifting for all the elements. Then we can sub the t naught into the formula here or in all the ramp function, and we can get the formula for part 1 to part 4. Then in order to compute x1, we have to sum all the parts together. So we sum all of them and we will get and we can simplify the equation here, and we will get the final formula of x1 in unit step function is this formula. Then secondly, we have to find x2 in unit step function. Okay, for x2, we can distribute the part into 2 parts only. Part 1 and part 2, they have the same amplitude, which is equal to 1. And part 1 is outward direction, part 2 is direction, so it's positive and negative. And the t naught is equal to negative 1 and 1. So we sum everything element together, we can find the equation for part 1 and part 2. And x2 is equal to sum of part 1 and part 2. And now we can get the x2 in unit step function here.
We want to get the zt. Zt is equal to x1t and x1t plus x2t. So we just combine the both of signal x1t and x2t, put the one expression to get the zt. And then for the graph, we have the graph like this diagram.
Then next, we have to compute the h in unit step function. The same thing, we have to distribute the graph into 4 parts. Part 1, part 2, part 3, part 4. But for here, they are just all unit step function. So we need to find the amplitude of part 1, part 2, part 3, part 4. So for part 1, part 2, amplitude are 2. Part 3, part 4, the amplitudes are 1. Multiply them with the amplitude. Then we need to find the time shifting element, or t naught. At here, t naught is negative 1. Here is 0, 1, and 2. We just sub in into the formula. And then the third thing is we need to find the direction of all parts. So here is positive, negative, positive, and negative. Now we have the formula for all parts. And now h is equal to the sum of all parts. We can get the unit step function of h. So now task 2, I'm required to find the g and h using the MATLAB program, and then also find the addition and convolution results between g and h. So for the first part, we need to compute g using the MATLAB code first, and also the h. In order to compute the MATLAB code for g, I need to find the unit step function of g and h. So at first, I can distribute the g into 3 parts to find the unit step function. So we know that from here, part 1 and part 2, ramp function, part 3 is a unit step function. So the first part, we need to find the gradient between the gradient of this line. And secondly, we need to find the amplitude of part 3. And the third is we need to find the direction, whether upwards or downwards for all parts, and the time shifting for all parts. Then we can just sub all the elements into their equation respectively. And now g is equal to the sum of all parts together. So this is our equation for g in unit step function.
After that, we do additional to get the zt. So we just combine both signal that we get from each signal, the expression. So after we put the signal, we sketch a graph for the zt after do addition for gt and ht.
We're going to talk about the convolution of equation, which is yt equals to x1t times x2t. So x1t regular function, which is to t 0 to 2 0 to t to 1, negative 4 t minus 1, which is 1 to t to 2 0 to t. Okay, x to t for rectangular function 1 negative 1 to t to 1 0 1 to t. So we just convolution, which is x1t and x2t equals to the integral, which is x1t x1 tau x2 t minus tau dt. So for first one here, x1 tau equals to 2 tau. So we substitute t plus 1 to 0 in integral. So yt equals to t plus 1 squared t to 0. For next here, we have the 2 parts of each integral, which is t minus 1 and 1. For second, 1 t plus 1 t plus 1. So first integral we substitute into first 1 to t minus 1. Second, t plus 1 to 1. So we combine together, it becomes to yt equals to negative t minus 1 squared plus 2 for 0 to t to 2. Okay, t next here is negative t minus 1 to 2. So which is 2t minus 1 we substitute here. So become yt equals to t minus 3 squared, which is 2 for 2t to 3. So the last here, which is no overlapping, so yt is 0. So this is the result for the convolution, and then this is the graph that I sketching here.
So now we need to find the convolution result y is equal to g comma v h. And first, we know that the formula of y is equal to integral h tau g t minus tau. So we have to convert h t to h tau. So this is the conversion, and we need to convert gt to gt minus tau. So we use this y equal to mx plus c equation to find the gt minus tau is equal to t minus tau plus 1. And then next we can do the piecewise analysis. For t lesser than negative 2, there is no overlapping, so y is 0. For negative 2 to negative 1, there is a partial overlapping, so there is one integration here, and we can get yt is equal to this equation. For negative 1 to 0, it's the same. It also have partial overlapping. So also one integral over here, and we'll get yt equal to a straight line. And for 0 to 1 is 2. There are two partial overlapping regions. So we have two integration over here, which equal to the two overlap regions, and we'll get the yt is equal to this equation, parabola. And for 1 to 2, in the time interval, there's partial overlapping. So yt is equal to this formula, and for 2 to 3 also partial overlapping, one integral, and we'll get yt is equal to this equation. And for t larger than 3, there's no overlapping between g and h. That's why y is equal to 0. And now we compute all the yt and the time interval together. It is the formula for yt over here in piecewise function, and we can plot the graph using this calculated formula. I have plot the graph using decimals, and this is our graph.
And I will continue for task 1 coding explanation for question A. First question is state that the graph for 1A and 1B. At here I state 1 is 1A for 1A. It's a triangular signal start from 0 and 2, and the amplitude is 1. This is all the plot graph. I state x level and y level. Also the title of the graph is a triangular signal. For S2 is a rectangular signal. Rectangular signal is start from negative 1 until 1 here, and the amplitude is 1 also. And this plot the graph, the x level for time, y level for amplitude, and also the title of the graph. Then the next question is said that for the graph additional between x1 and x2, this the additional of both signal is at here. We already state for x1 and x2 and form a new graph. Is at here I state for z2 for additional. And after the additional, we get all the answer here. Then for the last question is define the convolution between x1 and x2. At here I state for convolution is yt. The start of graph is start on negative 5 and the amplitude is 1. Also the graph the convolution. That's that. Thank you.
So now I'll explain about the MATLAB code for task 2. There are total 4 graphs to plot in task 2, which are G, H, Z, and Y. So for the first one, to plot GT, we need to first define the time variable for G, which is from negative 2 to 3 with time step of 0.005. This small time step can guarantee an accurate graph. Next, we need to define unit step function for G. This unit step function is using the anomalous function and logical function. So when t1 is larger and equal to 0, u is equal to 1 and vice versa. And next, we can just copy down the G that we have converted just now at the first part here, and then we can now plot G. We use the subtotal function because there are total 4 graphs, so 4 row, 1 column, and it is placed at the first, and we will plot all the graph in one figure. So this is the x variable, this is the y variable. We have used the plot function, and the properties is black color, and the width of the line is 2. The x will label with time seconds, the y will label with triangle G, and the y will be limit from 0 to 2.5. Next, we will plot ht after finish plotting gt. So the same thing, we need to define time variable for h, which is from negative 2 to 3 with time step, and the unit step function, and the h is the equation that we have derived in the first part. It is the unit step function of h. Then we can now plot ht using the same method, but the time variable changed to t2 and the y-axis changed to h. Then after plotting ht, now we can plot zt. Z is equal to g plus h. So first define time variable for z, negative 2 to 3 with time step of 0.005. So z is equal to g plus h over here. Is the addition operation, and we place zt at the third position of the figure, and we can plot it. The y variable will be z, and y level will be zt equal to g plus h. And then after plotting zt, now we can finally plot yt. The time variable for yt is negative 4 to 6. The time variable for yt is actually the time variable t1 plus T2, which is time variable of G plus time variable of H. Because we need to have the same vector length to carry out convolution function in MATLAB, because we will convolve G and H using the convolution function over here. So they have to be in the same length. So y is equal to convolution of G convolved with H, and we will multiply by the time step. And now we can finally plot y using the subplot function. We will place it at the last part of the figure, and using the plot function, plot the graph. And the y-axis will be this y, which is the convolution result between G and H. And lastly, it will be labeled with yt equal to G convolved with H. And our result will be this one. So this is our result of the graph using the MATLAB code for task 2. So this is G, H, and this is the addition operation result ZT, convolution operation result YT. In conclusion, for task 1 and task 2, the result for addition and convolution operation calculated using the mathematically way are exactly the same as the graph generated by MATLAB. So we have successfully described the response of an LTI system. Thank you.